Okay, let's talk about transformation of variables, which is random variables. So here we have distributed in three categories actually. First is monotonically monotonically increasing or decreasing. Okay, second thing is non-monotonic. Okay, okay, and then the thing is but they should be continuous. Okay, and third is discrete. Okay, so let's move one by one. First is monotonically increasing or decreasing. So here what happens, suppose this f of this sorry x is there and a variable. Now we are mapping it to y, which is equal to some ax plus b. Okay, so what happens, we directly say this f of y, like random variable in y domain, this density function will be f of x multiplied by dx by dy. Remember, it's not dy by dx, it's dx by dy and then mod. Okay, so let's see it by an example, like we have shown it, right? So what happens, suppose y equal to ax plus b, ax plus b. So here what happens, differentiating with respect to y, it becomes 1 equal to a into dx by dy, right, plus 0. So here it gives us dx by dy equal to 1 by b. So what happens, f of y, f of becomes f of x. F of x means what? X means y minus b upon a multiplied by 1 by here it will be 1 by a, right? So this becomes 1 by mod a f of y minus b by a, correct? This is your monotonically increasing or decreasing case. Suppose if it is non-monotonic, right? What does it mean by non-monotonic? It means कि at some particular value, like this particular value is coming at many places, right? Non-monotonic is increasing, decreasing like this, suppose, right? It's becoming like this. So then what happens here, what happens is we will give f of y equal to f of x at x1. Here x1 is one of the roots. Okay, so here what will happen, dx1 by dy1, okay, mod, and then plus f of x at x2, okay, and then here it will be mod of dx2 upon dy, okay, and so on. That will be the case for non-monotonic case. Okay, let's see by an example. Suppose you have f of x equal to 1 upon root 2 pi and then e to the power minus x square by 2, and y, the transformation given is x square by 9. So if you see, this transformation is non-monotonous or not? Yes, it is non-monotonous. So what will be the root if you see, right? X square equal to y. So what will be x values if you see, right? What will be x1? It's not linear, right? Mapping this linear, it will be 3 under root pi. And what will be the second value? 2 will be minus root 3 of minus 3 times of root pi, correct? These are the x1 and x2 things. Now let's find the dx1 by dy. What it will be? It will be, if you see, right, we have to differentiate with respect to y. So 3, if you multiply by, to differentiate, right, 1 by half, it will be multiplied by half, and then y to the power minus 2, which will be 3 by 2 root y. Similarly, dx2 by dy what will be? It will be negative sign 3 upon 2 root y, correct or not? Yes. So f of y, what will be f of y? It will be dx1 upon dy, right? Dx1 upon dy. This will be multiplied by f of x1 plus f of x2 multiplied by dx2 upon dy, correct? And the thing is, what is f of x of x1? What it will be, you have to keep x1, right? 1 upon root 2 pi. And what is f of x1? If you see what is f of x1, see, x1 is 3 root y. So what will keep 1 upon 2 pi multiplied by e to the power minus x square, right? X square means what? 3 root y square. Okay, and then this by 2. What will be 1 upon root 2 pi e to the power 9y upon 2 with negative sign, correct? Correct or not? Yes. And then what will be f of x2? It will be similarly 1 by 2 pi e to the power minus, again it will be square, right? It will become same 9y by 2. Okay. So what will become f of y? F of y will be 1 upon 2 pi and then f of x1, right? E to the power minus 9y by 2. But what is the slope? dy by dx1 by dy. What is dx by dy? Which is equal to 3 by 2 root y. 3 by 2 root y plus 1 upon 2 pi e to the power minus y by 2. And then what is the value at minus dx by dy? The value is minus times of 3 by 2 root y. Correct, no? And then what will happen if we multiply, right, these things? Yeah, I think we are meeting some under root. We'll keep one under root also. And then if you see, so here what is happening now, the final value, this final value will be what? 1 by 2 pi y e to the power minus 9y by 2 plus 1 upon 2 root 2 pi y e to the power minus 9y by 2. If we add this z, what will happen? F of y will be 3 upon root 2 pi y e to the power minus 9y by 2. This is your transform random variable. Okay, this is how we transform. And now coming to the third category, which is when random variable is discrete. Okay, when discrete it is there and it's not continuous, just we have to map this probability from x to y. How?